How's everybody doing today? We are in logarithms, and before I get into the uses of properties of logarithms, which is what we're going to be doing in our lecture here, we need to think about, well, why are we doing this, okay? The main reason is because we've already stated logarithms, what are they? They're inverses of exponents. Logarithms are inverses of exponents. So basically, solving exponential equations basically nothing fancy, but if I have y equals uh, 2 times 3 to the x, and I want to solve for x, okay, say maybe I know what y is, we don't have an algebraic way of doing that, okay? So what we're going to do is we need to learn to manipulate these logarithmic equations around so we can better solve is really the long short of it is we want to be able to solve logarithmic equations, and to be able to do that you got to know these three properties, okay? And the basically if you like puzzles you'll like today, because today is just kind of fitting puzzles together and taking puzzles apart. Okay, so you got three puzzle pieces, and it's the idea. So let's start right here with the product property. And it's the idea, if you take a logarithm base b and have two numbers, m and n, just any two positive numbers, right? You can split that out into addition, right, as log base b of m plus log base b of n, okay? We're going to show you when you come to class tomorrow, we'll do an activity that will make you believe this, I hope. All right? But now it's what you need to know is basically product property. Product is multiplication, speaks to addition. Those two go together, okay? Because of course, if I start on this side with log of m and log of n, and I want to go to the, if it suits my purposes to go back to one logarithm statement, I can go the other direction, okay? So I can work either direction on this product property, okay? Next is the quotient property. Quotient means division, okay? So if I have m and n are two numbers that are in a log statement and they're divided, I can break them out into subtraction, So again, what do we need to know? That division speaks to subtraction. Okay, those two go together. Because again, if it suits my purposes, and if I have a log base b of m, log base b of n, and I want to put those together, I can put them together as a division statement. Okay, basically, as you go from left to right, you're expanding, okay, if you will, and if you go from right to back to the left, you're compressing or simplifying, okay? So it's basically going to be expand and contract. Basically take the puzzle pieces out, put the puzzle pieces back in, okay? The last one is the power property, and this is the one you should see the most relevance right away for looking at the equations that we've been looking at. We've been looking at a lot of equations with x in the exponent, right? And then now, what we're going to be able to do is basically make log statements and take this x out to the front, okay? Take the x out to the front. In other words, take the number out to the front, and you end up with x times the log of base b of m. And the deal is now, once you're in the statement on the right here, all your rules for algebra apply. Okay, so you can go ahead and solve for x. Okay, so you'll use that quite a bit. All right, let's get to a couple of examples here. As far as these first couple are just, well, what rules are you using? Okay, so this example one, we'll just do this. This won't take us very long. This is just, if I take a 6 basically and expand it out into log base 10, log base 10, log base 10. I'm always writing that in for right now. I want you to always know if there's nothing written there, base 10 is implied. Okay, now so 6 breaks up into 2 plus 3. Well, addition speaks to multiplication, right? So the way that this equation got put in this form was the product rule. Product rule, okay? Now, in part B, down here, there's all log base B, and I have division, okay? X squared over y. And then wow, so I got two rules going here, right? So this subtraction was because of my quotient rule. Make sure I spell quotient right. And also, hey, this 2 is out in front. This 2 is out in front. The x squared, the exponent got out in front of that statement. So that was the product, or I'm sorry, the power rule. The very last one, the power rule. Okay? So quotient rule and power rule there are used. Notice you're typically going to, the way you would write this in order, you would have the x squared here in step 1, and then step 2 would be the last step. Typically is taking the exponents out to the front of each guy. Okay. Now notice in both of these statements, A and B, for this to work, our bases have to be the same. Our bases have to be the same. If the bases aren't the same, it's kind of like combining like terms. They can't really, the logarithmic statements can't talk to each other. Okay? All right, let's work into example 2. We have 3 examples here, a couple of quick checks, and that'll be it. Okay? So write each logarithmic as a single log. So basically, contract. Contract. Okay, so I want one log statement. I got 1, 2 right now. So if I have subtraction, subtraction speaks to multiplication. Sorry, subtraction speaks to division, right? So I can go ahead and write this as one logarithm, log base 4, and then I take the 64 over 16. I work from left to right there. So this is log base 4 of 4. Okay, it didn't say evaluate right now, so we're just going to leave it like that. Okay, we'll just leave it like that. We know we can evaluate that. We did that today in class. All right. So now this guy down here at the bottom, addition speaks to multiplication by the product rule. So the first thing I'm going to do is actually, but before I can handle that, I got this 6 hanging out in front here. So step 1. Log base 5, x to the 6th by the power rule. Okay, bases are the same, so I can work this together and go log base 5, x to the 6th times y. And it's just, xy. There you go. All right, so that's putting them together, okay? Let's look at this quick check real quick, just to get you a couple extra reps with this. We'll talk about this in class, but I want you to at least see these real quick. I'm just going to do these, okay? So if I got this guy right here, the first thing I'm going to do is log base 2 to the 3rd plus log base 4 minus log 16. Those are all base 10. Okay, 2 to the 3rd is 8. I can simplify there. There's no reason why not. Okay, so now I go ahead and say, basically, this is this addition. Okay, so I got one log statement, and the addition in the front here becomes multiplication. So this is 8 times 4. Once I get this subtraction, I'm dividing. Okay, I'm dividing right there. Okay, so divide by 16. So I get log base 10 of 2. Okay, that's your final answer. 32 divided by 16 is 2. Now, the reason I really want you to see this for sure is part B. Look at part B in this quick check. Can you write 3 times log base 2 of 9 minus log base 6 of 9 as a single logarithm? Okay, I want you to right away see as you're doing these, no way. Because the 2 and the 6, those, again, it's the like terms idea. It goes back to the like terms idea. 2 and 6 are not the same base, so therefore I can't combine them. Okay? All right, we have one more example here. One more example. Expand. So go the other direction. Make as many log statements as you can make. Okay? So this guy right here, we got T and U. Okay? So I'm going to break this up into two pieces. And division speaks to subtraction. All right? So basically, I'm going to write this as log base 7 of T minus log base 7 of U. And that's it. Okay, so basically the division sign becomes a subtraction sign, and I break it into two pieces. Okay, all right. All right, let's see. We got two pieces here, kind of the 4 and the p to the third. P to the third has to be one piece. And this one we've got multiplication. So we know multiplication speaks to addition. So by the product rule, we can take this and say log, we're in base 10 for this whole thing, 4, and then plus p to the 3. Step 1, that's pretty good. That's pretty good. But to get full credit, I would want you to see that p to the third, you got an exponent there. So by the power rule, you can bring that out front. So log base 10, 4 plus log, shoot, I didn't leave enough room for it. 3 log base 10 of p. Okay? All right. Let's try one more of these because we have a couple minutes, a minute we can do this, okay? And one more expansion here, or maybe two if we can get to it. So the expansion here, so I've got a 7 and a b, so it's going into two pieces. It's multiplication. So log base 2 of 7 plus log base 2 of b. Okay? Now this one, I'm going to tend to, before I do anything with the power rule or anything like that, I'm going to write this way to start. This is just my personal preference. Y squared over 3 squared, which is 9. Okay? I think that makes it a little cleaner for you. So now division speaks to subtraction. So I got log y squared minus log 9. And we're recognizing that this 2 needs to come out by the power rule, and I got 2 times the log of y minus the log of 9. Okay? All right. All right, one more. We got time for it here. So we got log base 7. We got an a and a b. Okay? So I got two pieces here. So I got log base 7. Ugh, sorry, too high on the 7 there. And I got a to the third plus b to the fourth, log b to the fourth. And go ahead and bring these out by the power rule. And we got 3 times log base 7 of a plus 4 times log 7 of b. Okay? So you got your quick checks in there. You got basically, because we need the reps for this. Basically, you expand, contract with your 3 rules. That's your lesson for today, and I hope you're having a great day.